Here we are, and let me switch this on. This has to warm up. So give me. Oh, Kira, are you at Foothill? Are you at Foothill?
No, I'm at home.
Can't hear you. Well, maybe our. How does this even work? I'm not. Funny. I still don't know. Anyway, all right. It looks like Foothill behind you. And I thought, Juliana said it was really cold, so you could actually come in if you wanted to. All right, okay. Okay, so this one is on. Okay, great. Fantastic. All right. Is the lighting all okay? Everybody can hear me? Yeah, everybody online can hear me. Kaden, Megan, Justin, Caesar. Caesar, where are you? Oh, yeah, I see. Switching the camera too. Yeah. Okay. Because there's online people. Yeah. Okay. Everybody should switch on the cameras. Rebecca also. Yeah.
Let's probably.
Yeah. That's Megan. Okay. All right. Anyway, you know what? What is it? 6:03. Okay. So here's this is my plan for today. And it's actually really fun. And in fact, I'm going to compress it a little bit because I wanted to do a little bit more today. A small exercise. Believe it or not, I had this idea when I was walking to the BART station in Fremont to get here. And it was really cool. But I thought, I want to do this, but I can't do it in the CS2A class because it's just using branching statements. And it's, we've gotten past the point where we need to do this, but it's actually a fun little thing. And then I thought, how can we get it done? So, and then I thought, well, it makes a really nice extra credit project for Jonah. Okay. All right. Okay. So here's the opportunity, and I'll describe it to you when we start up. By the way, I'm describing it to him because he's going to do this Unix command, but it's open to anyone. Okay. Anyone. If you want to do the same thing, that is fine. Okay. And it's going to be like, it's a small program. We'll talk about this in 15 minutes. I'm not going to talk about the code at all. I'll just say this is what it's supposed to do. And you're going to go ahead and do it. Okay. And yeah, and it'll be extra credit. And after that, here's what I thought we will do. We'll go with the code that Isidore posted on. Did you post it on Reddit? Yeah. Okay. So someone who shares the screen is going to pick up Isidore's code. And then we're just going to hack it. Okay. So we'll just hack it, change it around, restyle it, maybe even change variable names if nothing else is available. Yeah. So we're going to keep playing with it. And in the process of doing that, we'll make some, subtle changes along the way. Because he's already got it broken down into functions. So what we could try and do is say, well, you know what? Let's try and organize them into different functions, right? Let's take a little bit of this functionality and move it here. So we got two different functions now, right? And so we'll see how to do these mix and match things. And in the process of doing that, I wanted to take the opportunity, because this today is about functions and parameters and so on. Talk a little bit more about passing by reference and passing by copy. We've mentioned this before. But in the context of Isidore's programs and what we're going to do with it, I thought we'll do that too today. Okay, so I think that should keep us occupied for the rest of class today. So first of all, for what time is it now? 6:07, right? So hopefully done with this description of this idea that I have in about 5 minutes. And hey, Jonah, maybe you should take notes or something, because what I have in mind is basically just a very simple Unix command. Okay, and you're comfortable writing simple Unix commands, yeah? All right. Okay. So it's going to be a simple Unix command. And by the way, if you have a Mac, you can do the same thing on terminal. All right. So you can make it. And I said Unix because you can. It's simple. I'll show you. Right. It's the same as for Mac, but things are laid out slightly differently. And so you can have. All right. So let's go through this first. So here's what it's a simple Unix command, and I think we'll call it. This is a name that I thought of on the train, maybe. From silence to silence. It's a long name. It's not like a typical Unix command, right? It's going to be a long name, and it's hyphenated. From silence to silence, okay? And it is so simple, okay? By the way, and in the process of writing this, you will, if you haven't used it before, or if you're going to use it, you learn about a few simple library calls in Unix that are very useful. Okay, one of the things is that a terminal, you type who am I, right? One word, who am I, and hit enter on your machine. Yeah, You can actually share your screen if you want, right? Nobody else is sharing. Hey, Kaden and Pani also should share your, open your cameras. Also, Angelos, yeah, that logo. Is that a Halo logo? I don't know.
No, that's,
Yeah, something like that. All right. Yeah, Jonah, do you type who am I and hit enter? Yeah. Or you can, share and then do it too. Share your screen and then do it. It's actually easier. Share your screen and do it. And then you can just take notes in there in an editor. You can take notes of what this thing is about. How many minutes have I got? Yeah, I got 4 minutes. That's good. It is so simple. It is so simple. And it's so funny. It is so simple that it is funny, I think, maybe, okay? Or interesting. All right. So, and you'll see. Actually, I don't know if this idea has legs, but we'll find out, okay? Right. So anyway, what I mean is that while Jonah is getting ready, the reason it's got this name from silence to silence is that it is the 4 degrees of familiarity with people, okay? Theoretically, or fictitiously. What I mean is that the first time the command is run, it'll just return to the command prompt. Nothing happens, okay? Nothing happens, absolutely. Silence, okay? So that's the first step. The second time it is run, so imagine, this is the cool thing about it. It's got to maintain state somewhere, okay? It's got to maintain state somewhere. And I'm going to say it has got to maintain state in /tmp, right? And we'll get to that very soon. So what I mean is that the second time it is run, it's an independent run, but it should know it's been called before by this user on this computer, okay? So the second time it is run, it should say, hello, Jonah, okay? Which means the first time, you don't, for random people, unless you want something from them, you don't go talk to them, okay? But if you know them, it's the first degree of familiarity. You say, hello, John, and so on, hello, okay? So that's the first, that's it. That's, hello, Jonah. The second time it is run, you got to maintain state, which means that you got to maintain maybe a file in /tmp, which has this number. So 1, 2, 3, and 4. Anything greater than 4 is going to be silence again. So you're going to go through these steps. The first time it is run, silence. The second time it is run, it only prints one line. It says, hello, Jonah, right? By the way, Jonah is what you will get in the program by doing a command, by a call. It's a call. I think it's on Unix with, hash include UNI-STD. There is a call. There's a library call. We can find out. You can just Google for it. One call, which will just return a string. That is the name of the currently logged in user. So if it was Jonah, it'll just say Jonah in a string. Yeah, I think it'll be a character array, maybe a static string or something like that. But we can play with that. Okay. So that's all. So it should say hello, Jonah. The third time it is called, it is closer than hello, but not so close as dear. So it should say hi, Jonah. Okay. So and the fourth time it should say dear Jonah. Right. And the fifth and sixth and seventh and so on, it should just be silent again. Okay, that's all. Until the machine is rebooted. For that user, that is a cycle of the degrees of familiarity the program has gone through, and that's all it is. The program is called I don't know what we decided to call it, that long hyphenated name, okay? And it's going to be in your path, tilde bin or something like that, and I'll show you where to put it. And that's all it does, okay? The first time it is called. So what are the things you got to do? You got to do a switch statement, or you should experiment with both. If other people who want to try the same thing, right? A switch statement, or multiple if, else, all these things, because you're going to read the file. Again, you're going to use ifstream to read from the file, and you're going to use ofstream to write back into that file. And you got to Google for these things, or you can ask on the Reddit, and one of us will help out, okay? Because you read number 1, okay, from the file. Maybe the file is /tmp/ whatever that program thing is, $0 argv of 0 dot Jonah. Okay, so username, and so it's a file that you can deterministically find out. You're going to look in the file, read it, and it says number 1. So you're going to say hello, Jonah, and then you're going to overwrite the file and make it 2 now before you exit. That's all. Nobody knows what the hell is going on, right? Because it's in /tmp and all, but that file changes when you run it. The third time you run it, you're still going to get the file, but now it'll say 2, and so hi, Jonah. All right, and the third time you say dear Jonah, good to see you. Right? And the fifth and sixth and so on and so forth, anything greater than 4, you're silent again. Meaning that after you get to the dear stage, there is no more talking. right? Because there's like one mind. You know what the other person is doing. So maybe, it's not like linear, obviously, but those are the four, stages of familiarity with people that you're associated with, let's say, right? In this hypothetical universe. So the first you go through the, silent stage, and then the high stage, and the hello stage, and the dear stage, and then silence again. Okay, so I think it's really cool, and I think whatever that name was, I think it was cool. From silence to silence. Yeah. From silence to silence. Well, you can call it something else if you want. FSTS, right? I don't know. Give it a name. It's got to be in your path, and you got to run this. Anybody can do this, okay? And I've run out of time. 6:15 now. So that's it. Does everybody have a good overview of what this thing needs to do? You're going to do if statements. You're going to read files right into it, and or you're going to do COUTs. That's all, right? And the COUTs are basically just going to be outputs of if statements, and there's no complex logic here. And it's going to do something like brain dead simple. That's why it's not really part of this class in the sense, right? We want to talk about functions and more advanced stuff, but I think it'll still be fun because it'll give you a chance to exercise if branching statements in general, different ways of, because you can read the book and the book probably shows you 2 or 3 different ways, maybe, right? But you got to play with it, and here's something for you to play with. So you can play with this code and the if statement, because they're going to be like super duper important for the midterm. In the midterm, you may have, I don't know, maybe 10% of the questions. 10% of the questions in the midterm will revolve around branching statements. And so you got to be, and it's not going to be, it may not be branching statements that you've seen in questing or even in the text or in the modules. It'll be new ones that were manufactured for the test. And maybe, I don't know, it may even be that I change the numbers randomly every time. 2 people get the same question, they may get different numbers in if statements, yeah? So I think that's possible. Is it? Maybe I'll take a look. I thought Canvas had that feature and I turned it on or something like that. But I'll take a look, because that'll be nice. So everybody gets different questions, but they will be around if statements. This will give an opportunity to play with switch, ternary operator, right? You'll find ways to use ternary operators here. So use ternary operators. If not, do it one way and then do it another way again. And let's 3 or 4 people share the code. You'd say, well, Jonah did it using switch. I'm going to do it using if else. Yeah. And then Caesar says, well, you know what? I did it using just if and fall without the else statements and all these really cool things you can do. So each one will be a different flavor, or you can just reproduce what someone else has done with different messages. But essentially, this program is just the degrees of familiarity. Yeah, FSTF. So do this extra credit, okay? I think it'll be fun. It'll be fun, and it doesn't really eat into today's class time. All right, today we're going to be talking about functions, and I think it'll be fun. So who wants to take the screen and share their screen? Let's say, I don't know. If nobody volunteers, I will say, one of you can take it. Hey, Jink, where are you? I thought I saw Ian and Jink somewhere here. Not here. They're just online. I thought I saw Ian before.
I'm online.
Oh, I see. Oh, I see. I thought I saw your face. Maybe your camera switched off now. All right. Yeah. I think I remember seeing that. Good. Hey, Jink, you should also switch on your camera at some point. I wanted to ask you, why do you use you if it was pronounced with I, and it sounded very interesting. So maybe next time you're here, you can tell me that. Okay, in your name. So who wants to take the screen? If nobody volunteers, I'm going to say, does anybody volunteer? If anyone want to take the screen, here's what we want to do. You want to click on the link that Isidore posted in Reddit. We'll just go to the C++ code. And we'll still work in online GDB, right? Until about week 6, next week, obviously. No class on Thursday. Tuesday, if you guys want class, here's the option. All right. So how about this? Yeah. Hey, where's Ben and all? Yeah, go ahead. Someone else is saying something. Me? But I heard some voice. Oh, I see. Okay. All right, cool. No worries. Yeah. I thought Ben was, oh, Ben, you're here. Oh, your lights are not on today. You know what? Actually, you know what? Yeah, I think last class when I said your lights are really, lights are really cool. I thought I didn't say, I thought I said Ben, But Panini told me later, saying, you were talking to Brian about the lights, but it was Ben. Was that right?
Yeah, I was a little confused on.
Oh
I didn't think
wow!
Brian's
Okay,
lights were
that is.
that
I
crazy.
had no
Yeah.
idea. I had no idea. All right. Okay. Cool. But the lights were really cool. The cube effect. I really like that. Anyway, so how about what was I saying? Yeah. If nobody volunteers, I'm going to say, Zach, you wanted to take the screen, right? Did you say last class, at the end of last class, did you say you wanted to code or something? If you want to, you can code. Otherwise, I'm thinking Caden, right? Because Caden, you haven't really shared your screen yet. Yes? Caden? Where's Caden? I thought I saw him before. Caden was here. I don't see him anymore. Do you guys see him? There's two screens here. All right, who else wants to go? Matthew, do you want to take the screen? Matthew? All right, who wants to, why do I have to convince you guys? Because it is a fun experience, right? It's not like, it shouldn't be like, this party is supposed to be fun. You guys should have fun. That never works. But here, it's not like, it's different. The use cases here is different, right? You don't know it's fun, but it is fun, and I can force you to do it, because sometimes you won't discover how fun it is until someone twists your arm and says you got to do it. It may not work with parties, but actually it does work in class. And so sometimes if you don't want to code, sometimes I'll actually force you to code, and you actually have to do it. Okay. And that's why I'm not going for any of the people who actually volunteer usually. Okay. And by the way, I actually wanted to say this. I know some of you here, Isidore, quite a few, Rebecca, making headway on the questing, like 6, 7, 8, 9. Isidore, you finished everything, right? So I want to ask that don't use the time not to make headway. You'll have a lot of time in green, and to even finish the blue quest later. Use the time to interact with all the other people who are doing the earlier quests. So you can, people, and I see open questions. People have asked questions, and only a few people have answered, but you should take it upon yourself to say, I'm not going to do these advanced quests now, because you have a lot of time. I can promise you'll have a lot of time, especially in blue. Blue is not like super challenging like green. Green is definitely more challenging. I can agree that if you really do want to pop them as quickly as possible, you have a lot of time with blue. Okay. So don't just march ahead to the end, please. Because the reason I say that is because otherwise, the Reddits kind of look dead. There's not a lot of activity, but I know that people are working hard, but they're just working on different things and advanced quests. And that means the community environment doesn't work as well. Yeah, it works much better if people are all kind of talking about the same kinds of problems. And that's why I say, I'm going to toss out these extra credit problems. So if you're on an advanced quest, take a break. Work on all these extra credit stuff, okay? And then work on your own version of it. And say, here's my version, and so on. And you can comment on the versions that other people have posted. And that'll actually give you some stuff to keep your brain occupied. Yeah? Because if not, you're going to say, well, you know what, I'm going to do this. So you need some programming, C++ programming things to keep you occupied. And I think this is good. If you need more, all you have to do is ask. So suppose this problem that I described to Jonah is not your cup of tea, but you want to do an extra credit project and you're ahead and you want to take a break. All you have to do is just, send me a message, okay? Or post on the Reddit saying, I don't want to do, well, I'd like to do a different Reddit extra credit project. Don't send me email, okay? Just post on the Reddit under Jonah's thing, right? It's really cool, but I'd like to do a different extra credit project if possible. No worries, okay? And you just have to say what you're interested in, and we'll find a nice way of doing this, right? If you're interested in math, we can find a math problem you can solve in C++, right? Or, artistic stuff, we can create, or stuff that you can do in C++ that will create patterns on the screen. So many things. If you're interested in programming and you're interested in doing extra credit and you're ahead, if you're just struggling with 5 and 6, no, right? If you're past 6, don't do 7 and 8 now, okay? You'll have a lot of time after the final, after the midterm to do those things. So if you're past 6, you should just take a break. Next week you'll still have time to prepare for the midterm, as long as you're doing the extra credit and at the same time, because in the process of doing extra credit project, you're going to do research, how to do branching statements. How can I do these different ways of branching and still get the same effect? Because, that is really cool, isn't it? Suppose you have the program and you have it working one way, and then you say, I want to change the if into a switch and see if it still works. That is like super duper fantastic. Why? Because you have a reference right there in your home. You don't need the autograder, right? You know, this works. So if, now I do it in Switch, and if the Switch thing doesn't work, I can compare it to something that works. Isn't that cool or not? Yeah. Okay. All right. So all we need is, these things like, the familiarity, degree of familiarity game, right? One person to post one version that works. That's all. Okay. One person, like maybe Jonah posts, the first person to post a version that works. And then you're going to say, all right, I took that. That's my reference. It works. Everybody says it works. It works because, everybody's checked it out and no bugs reported, let's say. All right. And so that is my reference version. So I'm going to develop a version that has exactly the same behavior. Maybe you can change strings around. You can say, instead of, good to see you, you'd say, I'm glad you stopped by. But the behavior, overall behavior is the same. And but you play with the logic in there. So yeah. So you can say, well, I got this, it should behave exactly the same, but it's not. Why? Right? So all of those things you can, that is really cool. I'm happy that we have this option right now, because a lot of people are ahead. I expected a lot of people will be struggling in the early quests in the past quarters, because it's only before the midterm it really starts getting heated up in 8 a.m. classes. Okay, 8 a.m. classes, like week 5 is when people actually get into the assignments. Until then, we're still trying to figure out which class to enroll in. Wasting time essentially, in my opinion. Okay, so all right. Okay, so how about if Zach doesn't want us to take the screen, and Caden is not here. Caden is not here. All right, Caden's not here. Zach, do you want to take the screen? Yeah,
Sure, I can take the screen.
All right, great, excellent. Okay. By the way, you don't have to feel nervous that Dylan or Caesar saying, "Well, I hope I don't get picked." So it's all great fun. You should look forward to these opportunities. Think about it, right? So we only have like 6 classes left, 6 weeks left. So you don't have a lot of opportunities to just pick up screen and code with your classmates. Well, of course, you can do 2B, and so you'll still have extra credit projects and these weekly catch-up meetings when you can work on code. But it's not like this, okay? I don't know, right? I've taught 2A, 2B, 2C, all the way up, even grad classes. But 2A is always the funnest class to teach. Okay, I can tell you that. Because even in grad classes, even you know exactly what the hell you're shooting for. You know what the experiment's going to yield. You know how that person is going to work. It's like one person all the time, most of the time, right? But 2A, it is refreshing. All of you guys, each of you bring a different mix, different way of doing things. And so that is what makes a class quite lively too, I think, in my opinion. Thank you very much, Zach. All right, so here's what we'll do. Let's put some comments at the top. We used to do that in the past. But right at the very top, we'll say code for class today. Right at the very top, just hit top, right? Oh yeah, you want to put it there? I thought even above the header files. Yeah, a code for class and put today's date on it, and say we're going to experiment with Isidore's code and hack it and try to understand all the different ways in which functions and parameters behave. Yeah. Right, so this is the overall plan for today. Is everybody okay with this? All right, so this is, and I think we have enough time and we should be able to cover all of the material. Yeah, and this is, and as far as the midterm goes, I'll test you on all of the concepts until classes, okay? So you don't have objects in classes in the midterm. Well, we'll have a review on Tuesday. Tuesday, if you guys don't want to come to class here, it might actually work better. We'll actually do it on Zoom so that we can save a lot of time. And we can have extended review, right? Even more than 2 hours if you guys want. And we can start class sooner, like 5 p.m. if you want. Okay, people can come and join. And it'll be on Zoom. Maybe I'll do that, okay? Instead of a 2 hour here, I'll make it 4 hours starting at 5 p.m. And well, maybe 5 to 8, something like, okay? 4 hours, anybody can drop in and join and start coding. And, I'll toss out problems and you solve them. And it'll all be review for your midterm, okay? For example, like we have 5-6 people in class. And I could say, all right, Angelos, you're going to write a small program in GDB that will find the minimum of 7 numbers given to you as parameters, okay? Or given to you in a vector. And that's it, okay? And then you've got to do it. Now, the thing is, you can't say, well, I don't know how to do it. I'm going to go and find out how to do it. No, you got to imagine that it's already your midterm, okay? So if you don't know how to do it, well, okay, that's fine. Well, you can find out from someone else, maybe. You can ask in class. But you'll also get another problem. There'll all be short problems okay? But I'll make sure that they're all review kind problems, okay? Things that you can solve in 5 minutes, that'll give you lots and lots of practice. That's why we have this extended thing. And I don't have to, maybe, you know, at home, I don't talk so loudly because, you know, I'm just sitting in front of the computer. And, you know, here you have people all the way up there. So even though I have a microphone here, I'm trying to reach, you know, mentally all the people in the back. And so, yeah, this volume is okay. You guys can hear me, yeah? So I think if I maintain the volume, it's also bad. I get, you know, sore throat, not sore, hoarse at the end. All right, okay. So here's a couple of things I'd like to do. So yeah, all right. So here's what we're going to do. Okay. So let's go through the code and understand what he's done, and then we'll try and see how we can rip it apart. Is everybody okay with that plan? Yeah, Caesar, good. Right. So if you don't understand what the code says does, you've got to ask me or Isidore or anyone here, right, who understand what the code is doing. You ask them, you know, what's going on. You ask me, I can explain it and everybody will. So here's, all right, it enters main, and in main, we have a vector of players. Yeah. 46. Yeah. And a vector, a float vector of player guesses. So you're accepting all of the guesses. Yeah. Okay, great. And then you're seeding the random number. Everybody okay with this so far? Yeah. Okay, great. In fact, you know, let's clean up the code as we go and change the style, maybe even from Isidore style to something else. Put a blank line before the srand so that it's separated from the declarations, because it is really execution, right? So from that point onwards, we're starting execution. All right, great. Okay, so now you have an int total equals 0. Is total possible? Yeah. Oh, you're deleting it. You don't need it. Zach. Oh, I see you're putting blank lines there.
Yeah, sorry, I'm putting declarations up top.
I see. Oh, I see. You're calculating the total, and n numbers equals 10. Okay. Here's one of the things we can try and do. Okay, make that n numbers. I see you're cleaning up that way. One sec. Hey, Zach, are you doing things too fast? Okay, because some people may miss out, right? So I'll try and pace everything so that if you stay with me, then I hope we won't. Well, even if we lose things, people, I'll say, are you guys together? Okay, so I'll be doing the status check. Okay, so here's what we want to do. Size t n numbers. Okay, make that const. Okay, const for now, because I don't think we're accepting it from your const, and then change n numbers to all uppercase now, because it's const. It will use a convention that, you know, if it's a const, it'll all be uppercase. Yeah. All right, great. So we may have to change things inside of the code later on. Okay, n numbers. Okay. All right, n numbers equals 10. srand ints equals create random. And what is n numbers, comma total. Okay, all right. So here is one of the things that I thought we could do in class. I actually looked at your code, Isidore. Yeah, so it's really cool. So one of the things that Isidore did is actually pretty cool. However, we can improve it slightly, and we're going to do this. And in the process, we'll learn something very important about function parameter calls. Okay, so let's look at that function. So Isidore is, no. Before we go there, let's what is he calling? Okay, he's calling a function. Everybody on the same page. Here's our synchronization call. Is everybody on the same page? Caesar, are you going to sleep? With a hand on your chin on your hand, and all. Okay. All right. So, all right. Are you on the same page? What he's doing is calling that function called create random. What is it called? Your mouse. Yeah, create random ints. Okay. So he's creating a vector. It's a function. That function has got to be defined by Isidore. He's defined it, right? So we are going to go into that function now, the definition of the function, and change it ever so slightly. Okay, ever so slightly. Okay, so what happens here is, all right, so he's calling a function and says that function is given 2 parameters. The first parameter is a number of numbers to generate, and second one is total. Oh, I see. Total. Your randoms.
Total is, I don't know.
Reference parameter? Yeah. Oh, wow. Oh, I see. You're passing it by reference. Okay. All right. Okay. So here's what I was thinking, okay? Random ints. And all right, so the change I had in mind was that he constructs the vector and returns the vector. But however, it's, you know, in our case, it doesn't matter because we only have 10 items. But what happens is that when the function creates a vector and returns the vector, that happens, you know, in all the other languages, and we just take it for granted. But in C++, we actually have control over these things. It actually returns a vector, but it's going to return a copy of that vector, which means that entire vector has got to be copied over. So can we improve upon that? Okay. Now C++ lets you improve upon that. How cool is that? Okay. So unlike, can you do it in other languages? No, I don't know. In Python, I don't know. Can you pass by reference in Python? Unless you have a global or something like that. I haven't done Python in a long time. Okay, but maybe it's possible, in some roundabout way. But C++, you can basically say what he's doing with total. Okay, so he's saying, instead of making you make the vector and give me a copy of that vector, yeah, which so some copies involved here, I am going to create a vector and actually give you the vector for you to fill. Okay, so when you're done, all you have to say, I'm done. Is that okay? Is that okay with you guys? Yeah. All right. So that's what we're going to do. All right. So, and in fact, that will also clean up the other thing, because passing the total by reference is okay. It works, and technically it's right. But total by reference actually threw me off as a programmer, because it seems like it is got for me anyway. It seems like that kind of thing screams at you saying, I'm not passed by reference. I'm actually a copy, because it's like just a number. Yeah, and it's a second parameter too, and and there's no indication in the name. So these are things that we can factor in eventually. When we start cutting code, we can make it more easier. When we revisit the code, or friends or other people look at the code, we make it very clear that it's a reference parameter. All right, okay, great. So here's what we can do. Create random ints is going to take the first parameter, which is actually going to be our vector. Yeah, it's going to be our vector. And in fact, we can save on the number of items that we pass in the first parameter, yeah, and say the number of items is the size of the vector. Before you call this function, you're going to size the vector appropriately, and this function is just going to fill in the vector for you. Is that okay? Is that okay with everybody? So that's enough of a hack, I think. We want to totally mangle his function, okay? But I think we've introduced three new concepts now, all right? 3 new concepts in the process of hacking Isidore's this one function, okay? The first function that we're looking at. In fact, you know what? When I looked at this code yesterday, I thought, well, all right, let's do vector parameter passing, and so we'll have one idea concept that we can work in. So we actually got 3, right? And so we're going to pass the vector in. The second thing is we're going to get rid of the number of things, because we're going to size the vector properly before. Okay, so when we go to the call the function. Okay, where do you call the function? All right, so there you go. Right on the previous line, you say what is it? Random ints. Random underscore ints dot resize n numbers. Yeah, okay. So now you're taking this n numbers. Now instead of sending it as a parameter, you just packaged it inside of the vector itself. So you don't have to, when you send the vector, you don't have to send n numbers. Yeah, okay, good. So
would it make more sense to make it an array? Wouldn't it make more sense to make it an array, because we're not
an array
dynamic?
An array? Yeah, Justin, did you say array? Is it Justin? Someone asked me a question.
I'm Zach.
Zach, did you oh, Zach was, hey, was I the only one? I saw Justin's rectangle highlighted. All right, anyway, never mind. Or maybe you're chewing bubble gum and I looked at your lips and I thought, oh, maybe you're talking.
I'm chewing gum. I'm sorry.
All right, so yeah, I can't tell whether you're trying to talk. Right, Zach, you said passing an array is okay, yeah? All right, so you can totally pass an array. However, if you have an array of your own, you got to pass the array and the size of the array too. So it's 2 parameters, yeah? You can do that if you want, Zach.
Yeah.
Okay, it's a lot faster because you'll be passing it. We did that last class, didn't we? We passed a native array because it's, did we do that last class? Native array? Yeah, so you can totally do a native array if you want, and it'll be on a stack. You don't have to mess with the heap. But here is a way of playing with references. We did not get, if you use a native array, you don't get this chance because the native array is by default passes an address. Yes? By default, it is, so you don't get a chance to say, well, you know what? You're already being efficient without explicitly being efficient. Yeah? So there's no learning point there. Does it make sense? It's only because we pass by a vector, the function returns a copy, and then we create a copy, and these copies are involved. But if you pass a native array, we don't have this learning point because it is passed by reference automatically. Yes or no? Maybe this will be a midterm question. Yes or no? Does everybody understand what I'm trying to say? All right. So this is what this is an important point. Super duper important point. Does anybody understand what the hell I'm trying to say? Because if nobody understands what the hell I'm trying to say, this is no point in going down this road at all, right? Does anybody understand what the hell I'm trying to say? All right. So why Zach's question. Well, Zach, you asked the question. Where's Zach, by the way? All right, okay, all right, yeah. So you asked the
I'm sharing
question.
my screen.
Yeah, so Zach said, why don't we pass a native array? Yes or no? Now, it would work. First of all, tell me if everybody agrees that it will work or not. You can pass a native array that's got 10, 80 bytes in there. Okay, all right. So everybody agrees. So everybody meaning Jonah agrees. Jonah, Panini, or a few people, right, nodding. So everybody agrees that a native array would work, okay? However, if you pass a native array, we saw last week that it will only pass the hexadecimal number as a parameter. It's like 8 bytes of a hexadecimal number. It is the address of the array. Yes? Yes or no? Okay. All right. So if it's passing the address of the array, that is as efficiently as you can get. It's on the stack and you're passing the address. There's no copies involved. The other guy is going to write directly into the memory location who's you're holding on to. Anyway, you only pass the copy of the address. So it's already as efficient as you can get. Is everybody okay with this so far? The inefficiency comes when you say, I'm going to use a vector instead of a native array. So far. Now, one more small step. Everybody got the same step. When you say I'm going to use a vector, right? The inefficiency starts because, first of all, you're dealing with a heap, which is not on the stack. Forget about that. Heap means that, you're dealing with lots of memory. It's not a local variable like I and j, right? So forget about that. But the inefficiency in using a vector is that the vector is what is called an object. We'll talk about objects in week 6. Right? We know week 6 is a midterm. Week 7, we'll talk about, objects. No, you should probably start, reading about objects in week 6. But, I'm immediately after the midterm, Thursday, Friday, Saturday, Sunday, and Monday, you should start reading about objects and classes before you come to class, right? But anyway, when you use a vector and you say, return this vector, what C++ does, and, other languages also do, and we accept that, is that it will create a copy of that entire object and give it to you. And in our case, it doesn't matter because our vector is only 80 bytes anyway. Yes? Or, most of these vectors are 10 items, 8 bytes per item, 80 bytes. As and it happens very quickly, but still, it is inefficiency. Yes? Because it is being created there and given and it's copied. It should not be copied. You can pass a reference. And passing the native random ints native array like Zach suggested is the efficient thing to do because there's no copies involved. But if we did that, we would not have this learning point because we want to introduce this whole idea, which is valuable from your midterm perspective of what is this whole thing called a reference parameter? Why is it so important? If we use a native array, we'd never have a chance to use this reference parameter today. Yes or no? Because understanding that is actually super duper important for the midterm too, right? Why is it important? Because with the native array, we don't get a chance to use the ampersand operator that says when I'll make the vector, and I'm not going to give them a copy of the vector, I'll give them the original vector, and then this function of Isidore can write into the original vector and then say I'm done. That's it. It doesn't have to give me anything to copy back. I know when Isidore's function is done, my vector is already filled. There's no copies anywhere. It's as efficient as you can get, like accepting the minor inefficiency that is on the heap, not on the stack. Yeah. But other than that, is as efficient as you get if you pass the reference. Okay. So now, does everybody understand the learning point there? Because the learning point is what is important. Not just for the midterm. It is going to be like super important in your programming too. Because if I pass question number 6, maybe we'll just be using here and there we'll be using reference parameters. And unless you know exactly what reference parameters are, you could end up with time limit exceeded TLE exceptions in your code too sometimes, right? Because it may end up copying a big ass object when it doesn't have to, right? When you're supposed to be passing the object by reference. And so people have, maybe in RedQuest 6, red one, people have done that. But so these things, these subtleties important. That's why when Akash, was it Akash or Raj, poses this question about, well, how does putting the ampersand make all the difference? Yeah, that one simple character, one simple ASCII character makes a huge difference, right? Because just putting it there makes the program go from not working to working. But this is the significance of that change, passing the original instead of the copy. Is everybody okay with this? And the reason we spent so much time on this really is because this was really the major component of today's class. Today's class was really drilling in the concept of passing by reference and passing by copy and what the difference is, because it is like important in the midterm, but also it's going to be important in all of your programming downstream from now on. From now on, you need to know when you pass parameters, this is what we do, right? So one other trick, you lock in your closet and say, we're not locking your closet, you know, put in your shelf of tools, right? So you put it there and it will pick up lots and lots of these things. And eventually what will happen is that when you cut code, even in quest number 9 of blue, when you get to quest number 9, you're going to be pulling tools off from your, you know, tool chest and not even knowing, right? So, all right, I need this, all right, throw in a reference parameter. Oh, I need this, okay, you know, throw in this and so on and so forth. You'll be tossing lots of things together and without knowing that, but right now you're doing everything consciously. That is the only difference. And the only way you can get to the place where you can do these unconsciously, not unconsciously, right? Even I mess it up sometimes, subconsciously. So, you know, just do it on autopilot. Is just by doing it consciously, repetitively. And I think, you know, engineering wise, human engineering wise, doing it repetitively, consciously, that is the best way to automate anything. And because, you know, our brains, everybody is so intelligent that we don't want to waste time doing automatic stuff. And so if you ever find yourself doing repeated stuff again and again, we find a way to make it automatic, whether it's playing, you know, a musical instrument or anything. If it's repetitive, we find the pattern and latch onto it. And, you know, and part of it also, you know, part of it, you know, because, you know, I did some research during my PhD on this. Information theory is that by inferring a rule, we minimize the amount of data that needs to be stored. Does that make sense? When, you know, parabola, for example, right, y equals x squared, you have a lot of data points and you can look at the data points and say it's a parabola. But if you store all of the data points, it's an enormous waste. But if you use clever machine learning, really human learning, and figure out, okay, well, that is actually y equals 3x squared plus 7. And then all of a sudden, you only need 8 bytes to store your parabola. And the fact that, you know, vector, it's a parabola with these, you know, parameters. And so you've, you know, shrunk your, by inferring the right theory, you've basically eschewed your responsibility to store lots of data. So finding the right balance between the complexity of the theory and the amount of data you got to store, that is really what distinguishes, you know, what makes one theory practicable for a society or not, most of the time. Anyway, it's a digression that we shouldn't have gone into. Why did we start talking about that? Anyway, so all right, so here's what we're going to do. So we've sized it on the next line. Let's say total equals, right? Total equals, total, you know, on the next line, on line 61, change it, random ins equals, right? Change it, total equals. Now, can anyone guess where I'm going with this, okay? Because, you know, already I'm giving away what I'm planning to do, but you should be able to guess what I'm trying to do here and say, well, all right, this is what he's trying to do, right? So, and you're welcome to say that, okay? And in fact, you know, if you say that, maybe you'll even get extra credit. Right, total equals, create random ints and just pass it random ints as a parameter, nothing else. Okay, all right, so what are we trying to do there? Can someone tell me what we're trying to do there? Or what should this function do? You know, it's pretty straightforward what the function should do. Yes, it should take that vector and fill it in, but it's doing something else. It appears to be doing something else, you know, refactor. Yes, Brian. It is returning the total too, yeah? Great, okay. So we've got that function doing 2 things without using the reference parameter, except that we say that the first parameter is passed by reference, but, you know, it makes like total sense that it has to be passed by reference. It's a vector. Nobody wants to pass an entire vector, yeah, by copy. So cognitive load reduced for a programmer or someone who looks at this. All right, so, yeah, that's it. Right. So let's go to your function and change it. Now, do you want me to change it, or can someone other than Zach? Okay, because Zach is typing. Someone other. This is what I would like. Okay, and I ask, and few times people take me up on this. So where is this function? Yeah, create random ints. Okay. All right. You get rid of the whole thing. Actually, no. Yeah. Get rid of everything from 15 to 23. Okay. All right. Right. So, and then change the signature. Instead of int n, it's int, yeah. And then this should be, in fact, maybe Zach shouldn't have done this. And we should have said, okay. All right. So from now on, anyway, We'll put the ampersand. Okay, yeah, we'll do this, right? Ampersand in front of the random ints. No, in front of the random ints. This is what says random ints is passed by reference. It may be a huge object. It may be a gigabyte movie, but it's not a copy. I just get the address. That ampersand is what makes all the difference. Yeah, everybody okay with this? Yeah, we went through this 3 or 4 times in the past, so I don't want to belabor this anymore. Okay, now this part, Zach is not going to type. Zach, is that okay with you? All right. Well, he's going to type. He's going to type, obviously, but he's not going to type by himself. I would like someone else, right? Maybe Juliana, Rebecca, Caesar, anyone, okay? Just say, here, this is the code that should go in. Doesn't matter if it's wrong, right? And someone else could say, hey, there's a, it doesn't do it. We'll change it and so on. Someone should make a start. That's all, okay? Someone make a start and start calling out the code for Zach to type. And someone else could say, hey, hang on, there's an error there. Let's do some backspaces, okay? And then Zach will do backspaces too. So Zach is not going to watch out for errors and say, I'm not going to type in erroneous stuff, right? He'll type in whatever you guys say. Is that okay with you, Zach? Yeah, all right, great. He's going to type in whatever you guys say, but you got to say that into your speaker, and hopefully he can hear you. He can hear me, so he could obviously hear you too, right? And everybody should feel free. It's open season, really, right? Vivian, yeah, Kaden, all you guys at home as well, all right? So everybody should feel free to suggest what this should go. And, you can take turns. You don't have to do the whole thing, but start. I don't want to do this, okay? So there are lots and lots of these tasty cakes in this thing. I want to eat all of them, okay? So let's do it this way. Go ahead, okay? I'll just watch. Have a good time. Yeah? Maybe I shouldn't be in front of the camera, okay? So I'm not going to be in front of the camera, which means that somebody's got to be talking. If nobody's talking and it's silent, nobody gets extra credit, even the guys who are doing the extra work for it, okay? All right. So, well, not strictly speaking, that's not true, but you should be talking. No silence, okay? No silence. And imagine, right, on a YouTube video, and there's a bunch of people in there, and it's total silence. It's not worth watching. So you should be talking. Talk about anything. Yeah.
I was thinking that because it's random, maybe we can use rand to start with.
Okay. Great. Yeah. Hey, is this distracting, Juliana? Hey, you know what? Actually, I could turn this volume all the way down. Say something.
Hello.
You guys can hear her, right? Zach, can you hear her?
Yeah, okay.
I should have done this last time too. It's so
Yeah.
distracting to have.
The only thing is now you can't hear Zach if he speaks, or anyone that is at home.
I see. No, this has some speakers. You can hear them. You can hear them through your computer.
No, because my volume is off.
But no, if you're at home, you should be able to hear her, hear each other. Yes, on your computers.
We have no way of hearing anybody at home now because all of us are our computers are muted, your computer is muted.
Like right now, if anybody at home speaks, nobody will listen.
I see. But suppose I did this from home. And
Yeah.
that would be okay. Everybody can talk to everybody else. Now, how can I pretend that I'm doing it from home? Is there a way? It's the same meeting. I'm clicking on the same meeting. What do I do to make sure that the audio is exactly the same, and that people who talk into their computers can go across to the online students, and vice versa? No?
Maybe you should just turn your volume all the way down only when someone in the classroom speaks.
Well, that's like a walkie-talkie.
Yeah, and then
No,
you turn it
but
back.
I don't do that at home. I'm just sitting in front of the computer and talking, and I can hear all the other people.
Yeah, no, but the thing is the feedback.
The feedback is only half.
Oh yeah, I'm
That
turning on
only
the feedback
happens because
completely
we're
now.
together.
There's no feedback here.
Yeah, but then
you can hear those guys.
yeah.
But I'm saying you should be able to hear them through your computer.
Ours are muted
Because of your feedback.
because if we turn on them, there'd be feedback from
Oh, I see. Oh, I never, that is a bummer. That is a real inconvenience of doing it in class. I thought it should be exactly the same. Why does it take half a second? You know, the latencies are so from here it goes to Zoom, who presumably have infrastructure on the West Coast. Hmm? But they're all super duper fast now, right? Most of it is done in the hardware even. Hmm? Oh, it's still not as fast. Or maybe it's just money, right? It's just be money. At the end of the day, you could say, this is how much juice I want to throw into this. And if people can live with, you know, 0.75 seconds instead of 0.2 seconds of lag, you know, because, you know, you can have a system that predicts, yeah, this, you can make this margin. Hmm? You think so? Okay. Anyway, never mind. So yeah, hey Zach, you just have to type in, okay? People, anybody who wants to say something, figure out a way in which you can get it here. Hopefully, we'll do the next class from home. On Tuesday, we'll do the class from home, and we'll see if that works nicely. Yeah. Hey, all of you guys, next class on Tuesday, the review class before the midterm. We'll do it from home, right? So and then if it works nicely, we'll see. Especially if it starts raining and all, we are going to be at home anyway. So we want to make sure that it all goes okay. Yeah, it's not like yeah, okay, great, okay. Hey, you know, I look at you guys, you know, smirking, and I think, okay, well, it looks like they think that I want to be at home all the time. But that's not true. I actually enjoy coming here, but I'm at the same time, the rain is a factor that we should contend with. All right, go ahead. Talk through the rest of the code. Juliana, go ahead.
Well, that was my idea was just using RAND basically, but I really don't know how to proceed after that.
Maybe someone else can pick up from there and say, hey, this is how we do RAND. Okay. And Isidore and Chris and all, right? If nobody chimes in, you could also chime in, okay? And so everybody, but it's open season really. You should, you know, take a look at this. And Raj, Akash, you can say, is the font big enough for all of you guys to see what's going on? Yeah, okay. All right. So RAND. So Juliana said, let's use RAND. Juliana says, let's use RAND. Okay. So we're going to use RAND in there. But how are we going to use RAND? So you can say, yeah, someone could ask that question and say, hey, how do we use RAND? And then someone else could say, here's how we use RAND. And Zach is just going to type in the code. Yeah, that's all. So Juliana says RAND. Okay. So someone could say, how do we use RAND? And then we could, and someone else, you know, it doesn't have to be the same person all the way through. It could be different people. So maybe I'm going to ask, how do we use RAND? Okay, nobody asked, so I'm going to ask, how do we use RAND? And then one of you guys has got to come up with an idea of how we can use RAND. The thing is, I know that you guys know this, and nobody is still speaking up, okay? Because I know you guys are talking about, I've seen you guys coding, and then in the code that you submit, and also we've done this in class before, but there is this reticence, this kind of mental block that says, you know, even though I know I'm not going to say anything, and that's a bummer, you know, and just means that I'm going to keep talking and talking and talking, right? So maybe you can help me by making my throat less hoarse by saying, all right, I'm going to speak up too. Is that okay with you guys? Because I know lots of people here know the answer and nobody is talking, right? So if he does, those are things maybe I can test from time to time, right? Are these people really don't know the answer, or they, you know, even though they don't know the answer, they're not speaking up, okay? So from time to time, without this, I can sneakily put in questions. I know these guys know the answer, but nobody's speaking, okay?
So I was thinking, do we have like limit numbers, like from?
Yes. Thank you.
From
fantastic question. All right. So I was hoping someone would ask that. Okay, great. So Julian wants to know, is it RAND anything? Because RAND gives you a big ass number. And we said, no, it's got to be between 0 and 1,000. Okay. So there we go. Important milestone. We want to know that every number, and in fact, Zach can put a comment at the top saying we'll fill in the given vector, fill in the vector. Yeah, given the vector, given vector. With random integers from 0 to 9, 0 to, what is it? 0 to 1,000, 0 to 1,000, 0 to 1,000. Yeah, okay. And we know that we're going to fill in the vector. Okay. So someone, when I said, what is the advantage of arrays? Brian maybe said we can loop over arrays. Did you say that? Yes. Was that you? Okay. All right. Okay. So we're going to do that now. Okay. So vector is an array, right? So we need, and how many numbers do we need in that vector? Can someone tell me how many numbers we're going to put in that vector? But how do you know it's 10? No, but in this function, you don't know, right? Within this function, you don't know how many numbers to put in. You just got given a vector. So how do you know how many numbers you're going to put in there? Anyone can take a stab, okay? Take a guess. You don't have to be right. Yeah, I think that is what holds people back. People think that they have to be right all the time. And that is why they don't speak up, I think, right? But as a student, you are actually expected not to be right. So that is your best opportunity to be wrong as many times as possible. So you should just speak up every single chance you get. Because it's not like out there when you say the wrong thing, you get penalized, right? Or maybe you lose your job and things like that. But here, okay, you're a student. You have all the right to say anything you want and nothing can be, no, unless, anything that is safe, you should feel free to say, and so go ahead. Okay, so don't have to be right, don't have to be the right answer. You could say, I'm going to use ASCII characters here, and even doesn't make sense, that's okay. Maybe there's a creative way to use ASCII characters. Someone could say, hey, you know what, okay, maybe we can use ASCII characters. So it can be completely silly, and who knows, many times great things have been done just by branching off from silly, right? It's just not the question of going anywhere in particular, but just letting your mind be free to wander at any time, at any given time. You should just be like, not tethered, just like smoke. You can drift. And so when you train to be like that, I think you're just ready to innovate at any point, because you're not looking down any particular rabbit hole. And you just say, well, I'm just going to go this way. And you can feel it in your body. I think, I don't know, all wild hypothesis here, but I think, yeah, that's why you say, well, I don't care if it's wrong. I'm just going to try it. Okay, I'm just going to try it. Yeah. So you don't feel obliged to say, well, I don't have to be right all the time. And because, if I'm going to be right all the time, I'm not going to try all the paths, and I'm not totally free. So I'm just going to be totally free. I'm going to try everything as long as I'm going to be safe. So you establish your bounds first and say, I'm not going to kill or crash the program this way. The program is going to be alive. That means I've got a fair bit of leeway to figure out how to make it smooth and clean and beautiful and efficient. Yes? Because nobody starts out with a perfect product all the time. You start out with something that works. And I think I made this point in a LinkedIn post a long time ago. Scientists, what separates true scientists from people that just say, spend many, many years in labs doing experiments, even scientific experiments, professional scientists, but still haven't got a clue what science is. Right? And I've been like that for a long time too. So I know firsthand even, but I also know lots of my friends, you can persevere and do these things, but that last mile, getting to that place where was I going with that? What was I talking about? Damn, that was a really good thought. I didn't want to miss that. But I digress. Hang on. Yes. Yeah. Science. Yeah. What separates real science and gee, I totally lost that. Maybe it'll come back to me. It has these weird. I'll talk about something else, and I didn't want to waste your time anyway. Okay, so let's move on from that. So here we go. Right, rand percent thousand is going to take. All right. So how many numbers do we go into the vector? It is basically given to us already because the vector has been pre-sized for us. How cool is that? That is one of the advantages we get by using a vector, because you can just say vector.size and it tells you how many numbers, how many slots are in there. Yeah. So now you're going to do what Brian said a long time ago. You're going to loop through the vector using a for loop or a while loop. You can experiment and try different ways of filling it in. And you're going to say each slot is going to have this random number. And you're going to call, and srand has been called already in main, right? You only call it once. And so you're going to call rand repeatedly, and you're going to keep filling them in, right? 10 times. Or how, if the vector had 13 elements, pre-sized, it's pre-sized, right? And it's really cool that way, because as a programmer too, you don't want to have a vector, having everything in one place is easier for you to maintain. So you have vector, size it here, and because that's where the vector was created. And so you don't need, rather than size it elsewhere or make the size independent of something else. And so, right, so this is actually much better. You'll find, right? You do it the other way, you'll get bitten too. But this is a good practice to get used to. All right, so you're going to use a for loop. Someone else can, or even Brian, call out the code and Zach will type. You're going to use a loop, and you're going to go through from 0 to the bounds, whatever the bound is, okay? And fill the vector in with integers. All right, it's these random integers from 0 to 9. And at the same time, in the loop, when you generate the numbers, also keep track of the total, right? Create a vector, create a variable called total, integer variable called total equals 0 at the top before you enter the loop. And in the loop, you're just going to keep on adding to it. And at the end, you're just going to return it. That's all, okay? That's all. It's like, 2 more lines. Really only 2 more lines. Well, actually, because the braces and all, you got more. But really, you should go ahead and take a crack. And I think it will be fun. And meanwhile, let me try and think about what was, not that I'm going to bore you if I get it back, but I think it was really cool. I'm not, by the way, you guys should be talking, okay? Someone should call out the code and Zach should be typing. This shouldn't be any silence. Even if it's wrong code, that's fine. Yeah, right. Getting that thing, that's where I was going, yeah, it's okay to be wrong. It's okay to be wrong. And then you just, yeah, in LinkedIn, I made a post on LinkedIn and say, yeah, okay, I got it back, and it's actually useful and it's relevant, okay? So the thing that separates, Rio, the person who has a scientific, has got science in their head, even as opposed to someone who's just been working in science for a long time or a blind follower of science, is that the person who has that science in their head somehow actually knows that even though this path is very inefficient, it is correct, okay? The priority between correctness and efficiency is different, okay? That balance tilts suddenly when that awakening into a true scientist happens, okay? Now, correctness is like super duper important. Efficiency, well, is nice to have, but it's not as important as correctness. Now, someone should correct me if I'm wrong, okay? But I think that's what it is, okay? So what happens is that you have this huge morass of information out there, which is really a scientific maze. And you're all the time, even children, just trying to find theories and find out how it works. What is a parabola? So I don't have to remember the individual points. Essence of science, isn't it? Right? So we're just trying to find theories and try to fit them in our heads. And then we say that, we try, so, and we just say, it's important to go to the other side. We'll grab that, and this is inefficient. We're going to iterate repeatedly, okay? We're not going to let go of what we've got, which is correct, and do it. And what the non-scientists do, I think, is that they will go down, experiment, and do a lot of experiments, try lots and lots of different things, but they are not guaranteed to be correct. Even they may look efficient too, right? And many of them do look efficient or better than the correct path that the scientist knows. The scientist knows a correct path that goes to the truth, but it's inefficient. But a lot of people don't have the correct path, but they think that there are more paths that are more efficient, that are more worthwhile than the inefficient path that goes to truth. Now, the prudent approach, I think, which is really what I think makes the scientific mindset, is saying prudently, we should pick the correct path first and only go to an incorrect path, regardless of how tempting it is, even if it's infinitely tempting. Only if you have some guarantee that it's going to be correct, or we don't have to give up something that's inefficient but is correct. So meaning that you always have a place to call home. Essentially, that's what it is. Okay, you find your home, find where you need to go, and after that, you can wander as much as you want. Okay, so that and it all ties back to what we're trying to do, is that then you won't be afraid of making mistakes. Okay, so when you know what you need to do, then you're willing to take chances. You can, because I have what I need to do. Then after that, it's just a billion here and a billion there, right? So it's it's pretty soon it adds up to real money, or it doesn't add up to real money. But once you know where you need to go, is finding the path in the graph. That is the most important thing, right? Even as students, and OWL relates to this too, right? As students, and in any college, unless you go to a counselor and sit with them and talk and have a heart-to-heart with one of our, and that's not rare, that's rare, right? People don't go to our counseling office and sit down and say, this is exactly what I want to do in my life. And most of you don't know. The thing is, there are too many options, okay? And then you could try doing this, and lots and lots of things, and you just dilute yourself. So, but if you find out where you need to go, and some people actually find out, they are able to channel all of their energy in one instead of many. And obviously, not that they're more intelligent. Everybody is exactly the same intelligence, I think, right? So, but they're able to channel more in one thing. And so they're able to progress more. And so that is why planning all your coursework is so important. I stated this before in a previous class. The reason why some quarters are worse for me in CS2A than other quarters is maybe because the fall quarter offers lots and lots of tempting and hard courses, okay, which are not available in other quarters. So you got to pace these things. That is why it's like super duper important. I think Stacy or someone reminded us to send in a message. I posted it on Canvas a few days ago. So you have to sit with the education. I don't know. I forgot what it was. I actually copied and pasted education counselor or guide or something like that, right? You got to go and sit down, have a chat with them, because otherwise, you know, professors are not going to get good students, right? They'll all get students that are all overloaded in one quarter, and then the other next quarter, they're all going to go and party, you know, on the beach, right? Because there's no work. And so it's very bad at planning these things. And so you got to sit and make sure. That is why that email, that, you know, that announcement is super important. I'm glad I got a chance to say that today. Okay. All right. So is everybody okay with this? You're going to do a loop. I'm going to step away again from the screen so that you guys talk. You're going to do a loop, fill up everything. You got to do the rest of the function. Do the rest of the function. Anybody, okay? Doesn't have to be, you know, just the students in class. Anybody outside from, you know, in the online circle, anybody could call in the code and Zach will type it in. Okay. Is that okay? All of you guys? Okay. All right. So go ahead. Okay. So you're going to create a variable called total, set it to 0, add it, and all of that. Do all of that in a loop. This is all practice for your midterm. All practice for your midterm, right? In your midterm, you may have a loop and say, you know, which one of these is the right way to fill in the loop. And you got 5 options. Okay. So unless you've done this a few times, how would you know? Yeah. And you may get 5 fragments of programs because, you know, in CS2A, in the first 6 weeks of CS2A, you don't get that many logic type questions. Okay. Questions where you have to dive into the logic and figure things out. Actually working through things like math proofs and all, that'll only come past even in question number 7, 8. After you start doing binary search and all, in the final, you'll have to think through the answers. In the midterm, most of the questions are going to test you on control structures, mainly knowing whether you know how to use things together, okay? Not whether you can use them to solve problems. That'll come later. So in the midterm, you're going to be given like 5 code blocks, okay? Please pay attention, okay? This is a classic question. You may get given 5 code blocks, and you know 3 or 4 lines, 4 statements, 4 or 5, you know, if statement or something like that, and a question that says which one of those code blocks is syntactically incorrect. Okay, how would you figure that out? So you got to turn yourself into a computer, or you got to copy that and paste it into your IDE and wrap it around in a main and compile it and figure out, you know, go through the morass of information the compiler spits out, and then say, okay, all right, the compiler is actually telling me that this is, all right, that means you'll only get through like 20 questions in 40 in that time. You only have 1 hour. Okay, so you get given these, the way to do it is like a program. Practice a lot. So you look at it and say, well, you know what, B is probably wrong. Okay, I'm not going to compile B. Hey, check B, bam. And you can move on. 10 seconds for that question. Yeah. And so those are tricks you pick up just by practicing. Right? If you practice something repeatedly and someone says do that, you just do it and move on. Right? You don't have to prepare for it, sit down, warm up, practice, and then okay, unwind and move on. Right? So that you only do it a certain number of times. After that, that theory I had, but we're just lazy. We just have to figure out ways of doing it, automatically, repeatedly, autopilot. So someone says do it, you just do it and move on. And it is like super important when you get to coding actually. CS2B, if any of you is planning to do CS2B, you can't even afford to be thinking about these things, okay? What I mean is that the problems there are going to be of a different level in the sense that you'll be thinking more about the problem itself or the data structure itself. We have these three classes. I like to imagine them as three different ways in which we teach. There are three different phases of C++. First is just mechanics, which is, stuff that you can use to build things, structures. You can build structures with these things. That is CS2A. It gives you for loops, all these things, even pointers, how you can get these pointers linked to each other. CS2A. That's it. CS2B. What are all the different things that you can put together using these shapes? Is that a complete semester or not? Yes? Because using these, you can create a whole lot of interesting things. You can create something like this, you can create something like that, okay? And each of those has interesting properties in math, yes? Or in computer science. So you can say, I want something with two, pointers, tree, and it can be traversed in this way, multiple, graph. And so you're going to study that, just different structures and different ways in which these structures can be manipulated. CS2C is final, okay? It combines both of those, because you can't get from here to here without doing this. You got to know how to do the, make use of the tools. Then you need to know how to use the tools to make things out of the tools. Finally, in CS2C, you'll get to see, how can I solve interesting real problems, okay? They don't have to be useful problems. Interesting problems. Like I want to find, a prime number that matches the digits of pi, all right? Just the nth digit, right? It's interesting, but useless maybe. But still, interesting. So can you solve interesting problems using what you already know? So that is the beauty, is that at no point are we asking ourselves, can we do something using things that we don't know already? And that is the beauty of a systematic approach. If you do this systematically, A, B, and C, blue, green, and red, at no point you will ask yourself, to do this, I need something that I don't know already. No. If you do it in sequence, in the order that I've recommended, every time, any problem you need to solve, everything would have been done already. So when you go to solve the real problems, saying, hey, how do I get this thing, in the right order in the shortest amount of time? It could be anything, sure, grocery list, sorting, right? Simplest of all problems was I think one of the most profound and interesting too, right? Sorting. And we'll cover it in CS2C. And you can bring all of these techniques to bear on and saying, well, and do that. And all of that needs to be automatic. So when you're doing 2B, you can't afford to be thinking about individual control structures. Do I use a while loop or a for loop? Strangely enough, I've seen discussions on Reddit, and someone says this algorithm doesn't work, and someone responds to this question saying, hey, switch it from while loops and for loops and it works. You're right? Okay, but it's funny. It has done that for me too in the past. Okay, and it's funny. It's the funny thing for me is that actually seeing that's observed by another student, right, in a forum, because I've experienced that. In the past, when I used to program, I've made that change and said it worked. And eventually, after lots and lots of experimentation, the conclusion I came to, anyway, was that while loops are a lot more error prone than for loops, okay? If I use while loops, there's a whole lot more ways in which I can go wrong. And so we tend to, be safer when we use for loops. And that was the conclusion I came to. But that was exactly the same observation, right? And you can say that too, in saying, well, why doesn't this work? And say, you change this from this to that and it may work. And you can ask, why does it work? What is the difference? So all of those are useful. All right, I'm not going to say anymore. Every time I come back here, I'm just drawn into talking, right? Someone should remind me. Just pipe down. Right, so finish the loop, and that function should return, okay? That function should return. What time is it now? 7:16. All right. Let's plan for 7:30, 7:20. Okay, so 3 minutes from now, we should have the function completed in 3 minutes. How about that? Either all of you together, just find out some way of completing that function in 3 minutes. Okay, 3 minutes, it should be done. How about I go and take a drink of water? When I come back, it's done. How about that? Okay, yeah, 3 minutes. Great. And if you need any help, you can ask, okay?
Thank you.
Just ask, I know people, there are people who can help.
Is it this one? Is it this? You click on down? Really? Oh. I want to like get some STD virus.
What? It's like that. Yep, it is.
What's up? Dude, how come your thing doesn't have a webcam? I find that so.
I don't know. I wasn't looking for a computer with a webcam when I got the computer.
What were you looking?
You know, we got it in like 2019 when Zoom wasn't.
Oh,
you did
yeah,
and
fair.
everything. And now if I bought a computer, yeah. Well, I mean, and I have an external webcam, but
You're in high school, right?
what? No, I'm in.
Oh.
I'm a freshman.
But don't your other professors like hate that you?
I forgot to do Zoom classes.
Oh,
I didn't think this would be a Zoom class, but
I see.
we are.
I feel you.
Yeah, I have an external webcam at home, but it's attached to my like PC at home.
Mm-hmm.
So
Zach, can you hear me? All right, I think you could finish it by having I less than vector, or no, not vector, random underscore ints.
Yeah.
Dot size.
Is it done? Is it done?
And then put some parentheses. Yeah. Or you know what to do, right? Yeah, I plus plus. Yep.
Or someone calling you out?
he is helping him.
Oh, he's zero.
No.
Oh, Brian. All right, cool. Yeah, he was the one who wanted to do the loop over arrays. Yeah. Okay.
And then yeah, you can make total.
This is
No,
for the
a
guessing game.
different variable.
Yeah, I did.
Yeah,
I did. I already did this thing.
I did as well.
Well, maybe you should help
Actually,
him
mine
out.
had like
Maybe
No,
say
but
something.
the thing is, I didn't use a loop. I did a bunch of like C-outs. I like made it super easy.
yeah, I don't even remember.
I'll show you my thing. Let me find it.
Mine like worked, but for some reason, like it didn't.
Yeah,
work
it's
with
probably
my
just
CPU
total,
For some
right?
reason, my CPU just like kind of barked out.
Total equals 0, and then you have
I
total
mean, I can play like.
equals or
Well, I mean,
plus
if it
equals.
works, it works.
Yeah. You know what to do, Zach.
It's probably just not the most efficient way to make it.
Yeah, definitely not. That's what it is. That's what the issue.
If if it works, it works.
Are you in Jeff's class? Oh, yeah. So it's only Chris. No, not, it's 10.
And
Oh,
then return
no.
total.
Are you in Jeff's class?
What?
Are you in Jeff's class?
No.
Nobody.
What does he teach?
No, all of
What's
that.
good to
all
me?
those goodies belong to Jeff. Right, but in order for me to.
Maybe I forgot something though.
Damn, I literally had written this entire. Okay, I think I have it. So it's not.
So running through the debugger to figure out where it's failing, but it's been. I don't know.
I'm just gonna write this in a new online GDB page, but I had it. It was like so.
Yeah. You actually got it working? No, I didn't get that thing working. I was working on so that thing that I was telling you about. What is this?
The thing is, if I posted it,
Oh,
everyone
yeah,
would be
yeah,
like,
yeah.
dude, what the fuck? Like, could have
Yeah, sure.
did this like a week ago, 2 weeks ago.
I gotta watch now, right? No. Oh, it is my name. Yeah, you're doing the.
I mean, you're talking about the quest.
No, this is that number guessing game.
Yeah, the game.
Oh, is single player okay? Yeah, single player. Yeah. Oh, I see. Ready to play, yes. Oh, wow!
Welcome to the number guessing game. Enter.
But they're arrays of strings?
Yeah.
So vector of strings?
Yeah.
Like,
No, it's printing out individual strings as it goes.
Oh yeah.
where are
I
you
see what-
storing that? Where are you storing that?
It's just a function. Yeah,
Oh,
yeah, I'm doing like the C outline.
No, but where are you getting those strings from?
Yeah. Okay. So it's working now.
So can I
Yeah,
can you
so
show me?
I
So,
can
and you
keep
got it
going
from
now.
online, you went to ASCII art or something like that?
Wait, is it with Y? Oh, yeah, Brian.
Oh, I see, and you guys just put them in. Oh, I see, okay, that's nice. Why don't we do, keep that.
Yeah. So it was like slightly different. So I didn't flush this
Why
out.
don't we do something
I haven't done
Oh,
that.
like after 5 seconds.
Yeah. Well, I did a sleep between this and then this. I didn't. I don't. How do you do that?
So
Oh, I see.
at the end
Okay,
of
okay.
the line where you have everything,
Yeah.
where you have all the numbers,
Uh-huh.
do /r at the end.
Oh, but okay. So I did. Okay.
I think that's the access for the end. After the sleep, you see out dot. I think is
That art was up on.
So let me just try this.
Well, after you put in a number, so like the thing you.
So /R, and then on the next line.
So I don't know why it's crashing.
I see.
Oh no, that's not gonna work for me though,
But once
because
you get it, once you've got it,
the
ready,
problem.
you should totally share that on Reddit.
the-
Yeah.
I think if I did that though, it's gonna wipe it out after every. Let me just try it, but I don't think it's gonna.
Yeah.
So, let's see.
Okay, so it's gonna show me. So here, I think it's gonna wipe out like.
Is it done? Is it done?
Yeah, see, it's gonna. Yeah, literally just.
Wait,
wiped
why
it.
did that
So
happen?
right here is where it never gets.
What's the /T for?
That's to tab it over, just so it looks.
Do you want me to do
Oh,
it?
I see.
Do you want me to do it? Yeah, I can do it too.
So
Okay, in
it's
that
kind of
case-
like a fake array.
So I can show you and I can tell you and then you can.
Oh, I'm not typing, right?
You're not talking, you're not typing.
So it's gonna spit out 10
But that's
numbers.
Uh-huh.
But basically, all we want to do is
And then
assign
I'll
the
just,
number into the corresponding index or vector that's passing. So random in square bracket I equals that. And that number, you also add it.
It doesn't say what the error is. Like I
And
could.
So-
that number you have to throw.
See,
That's all.
okay,
I'll fix this part to make it a little-
and then this, it gives you the int. Oh, so, okay, in that case,
Is
just.
everybody okay with this? Yeah. So what? Zach-
I think that's a
Oh,
different page.
Wait,
It's not this.
is the tab good? Is it just like,
I think this
click
tab.
around in here, is it good? Yeah, it is.
No.
So, okay, instead,
In fact, no. All right, hey.
just do it like
don't
right
push
here
back.
before the double average, and do the C out, and
Yeah.
then do
Yeah.
a slash.
It's a
R.
common thing that maybe I should talk about this, okay? Here, don't use pushback on a vector that has already
And
been
then
sized. If it's
Here, it
already
should
been
just do
sized,
nothing, it should do the
it's
normal
got 10
thing.
items. Then you're pushing back one more item, it's gonna be the 11th item. Yeah? Don't, so it's been sized, so you're gonna say square bracket, bam, like that. I'm gonna assign two, element 0, element 1, element 2. So you're gonna assign it, right?
So, okay,
Yes,
yeah.
yes or no? Everybody okay? Yeah, it's just correct, Zach.
So
Or
now,
maybe he hears me.
If you go, scroll down.
Yeah, there you go.
So before, I don't know, after this, I guess you could do a
Okay.
sleep for 5 seconds to
so
go like
that
and memorize it
works.
for 5 seconds and then see out
Does that
flush.
Um,
So you're saying sleep
Sleep for like 5 seconds.
5,
what's up? Well, you guys started-
and
And then
then
I think it's see out dot flush.
yeah.
I don't know what the exact command is. I looked it up and it didn't really. I think it is a function. I think, yeah, you need parentheses.
Yeah, it just doesn't make it.
Then that should be good. Now we'll try running.
I have a vector of defined deltas, that's just collecting deltas, right? So it's a vector.
no-
that's
there's
sitting
a-
there,
We pass in a vector.
And it has nothing there, right? So it's telling you to push back whatever.
It's sleeping for a long time.
Okay, that didn't do what I wanted it to do. Because here it's already printed out all of the numbers.
Yeah,
right?
right. Yeah.
So then why? Because it's left there for 10 seconds, I think. It, what the heck?
Well, it's slept up.
Left it there for the first time, and then it should have printed everything out,
Mhm.
and then it should have done, I don't know.
Yeah. I am.
Yeah, but it's important that you do that. Everybody has to do that, okay? Everybody has to read over the code many times. Otherwise, I tell you, you'll forget all of this. You guys are good? All you guys good so far? Okay, thanks. Everybody okay? Good? All right, okay, Zach, go ahead. What else do we want to change? What else do we want to change? Return total, right, calculate errors. Yes, okay. So I wanted to make a few stylistic changes, right? Stylistic changes. Let's go to main, go back to main, all right? All right, so take a good look at the numbers on the next line. Yeah, what we want to do is before, but one more cout. So let's prepare the user a little while, right? One more cout just before that, after that, right? So say cout. This is a math estimation game, arithmetic estimation game, right? You will be shown numbers, and then the numbers will be erased, and you have to remember what the average is. Okay, so just prime the user, and then you say standby. Okay. This is an arithmetic guessing game. In fact, you don't even have to say that, right? You'll be shown a set of numbers. You have to estimate the where you will Yeah, and arithmetic guessing game, right? No, it's not a. And where it will be shown a set of numbers. Yeah. You don't have to say 10 because our thing is a variable now. You can say a set of numbers. Yeah, numbers. You can say numbers. Yeah, /n, and on the next line you can say, yeah, endl, right? Endl is better. Yeah. In this, oh, maybe not. So it's a semicolon. Yeah, get in the habit, right? And see out, one more see out, and no black line because it's just one paragraph. See out also next to the previous see out. Yeah, okay. And this is a set of numbers. You will have to estimate their average in 5 seconds, after which the numbers will be erased. Seconds, after which the numbers will be erased. Right? And then you say stand by and sleep for 1 second, okay? Stand by for the numbers and sleep for 1 second. And it just improves the user experience a little bit. They're not making any logic changes here. Yeah? Stand by. Yeah, stand by for the numbers. I think it's 2 words, not hyphenated, but numbers, dot, and then sleep for 2 seconds. Yeah, all right. And then sleep for 2 seconds after that. And you need endl and then sleep for 2 seconds. Yeah, all right. Now take a good look at the numbers on the next line for the next 5 seconds, right? Okay, all right, good. Now what we want to do is, all right, so now scroll down. And all right, so you're printing all the numbers, /t, okay, that's fine. And then /r flush. And then you're sleeping 5 seconds and then you're erasing them. Okay. All right, great. So far, I don't think we need to make any changes. That's okay. All right, let's go to float guess. Float guess. Did we calculate the average, by the way? Did we calculate the average at all? We didn't calculate the average, right? So you can say float guess, comma, real average. Guess, comma, real average. Hey, Isidore, how did you do it if you didn't calculate the actual average? What? There's no variable called real average. Oh, I see. You're just calculating the errors or something like that.
Yeah, I'm calculating the errors.
Differences and, but in order to calculate the differences, you need the average. Yeah.
Yeah, and that was the total I passed by reference that we modified the.
Oh, I see. We changed these things around.
It was kind of messy, but I passed the total as a reference.
Okay.
And I added the.
Got it. So we are changing the logic a fair bit, which is good because now you get to know 2 different ways of doing the same thing.
Yes, now we need to find another way to.
We need to find another way to make this work.
Yeah, exactly.
Yeah. Okay. So we've actually changed it and broken it purposefully, as it turns out, because now we're going to put it back. But the challenge is not to put it back the way that Isidore had it. Okay. You got to do something different. Now I'll do one way and you guys should do it another way. So, well, you can rewind. Okay. You can get the code that Zach will post and then say, I'm going to rewind, erase all the code up to line 89 and do it yourself. Okay. Each one should do your own and post it. Okay. When you do this and post it on Reddit, it is practice for your midterm also, because you'll be getting, familiar with these concepts. Okay. All right. So now what we want to do is, what happened to the browser? Hey, Zach. Did you lose that code?
Sorry, my monitors are bugging right now.
Is that code gone completely? Oh, it is there. It is there. All right, great. Thank goodness. All right. So real average. Now you can say real average equals, after string name, you say real average. After line 80, hit enter. Line 80, yeah. There you can say, real average equals. And then you can say get average off, right? Get average off. And then you're going to pass the vector by reference, okay? Another function that you are going to define, it is just going to be 2 lines, but you are going to do that. Yes? Yeah? Okay. Now, I think we shouldn't take as much time as the last time before. It's only 2 minutes, okay? If you don't do it in 2 minutes, I'll do it. So only 2 minutes. Someone do it. This function should return a float. it should return a float average of the 10 numbers that are given to us, integer vectors, right? So the vector has vector.size elements in it. Yeah, 0 to whatever the vector.size is. You're going to calculate the total, okay, and divide it by the size. That gives you the average, and you're going to return it. But it's going to be all done in float space, not integer space. Everybody okay with this? Everybody okay with this? Online? Megan? Yeah? Okay, Justin. Where's Megan? I thought I saw her before. Yeah, there you go. Hey, Megan, I can't see you because, the camera is off and I can only see your hair. Yeah. No, you can angle the thing. Yeah. Okay. Yeah, you can angle the camera. Right. Okay. Yeah. So everybody okay with this so far? Yeah. Okay. 3 minutes. Do it. So we need this function. Someone call out the code and Zach is going to type. And in fact, you need to create the declaration. You need to create the body, everything. So you need to get the average. Yeah. So you're going to say float, whatever that thing is, get average of. Yeah. Okay. And then you're going to pass it by reference. Okay. And it's all really cool. When you experiment, you can try to see what happens when I leave out the ampersand. Yeah. All these things you can play around with. When I was learning C++ very, very long time ago, I don't think I was forced to do it in all these different ways. And it was just a matter of luck that different ways of many different things I'm doing. Eventually, I cover all of these things. I think the disadvantage of that is that it takes more time to cover all of that ground, right? Because if someone has said, you don't have to cover that many times in order to get totally familiar with that, like a teacher does, like I'm doing in class, I could say, well, this is something that you need to practice. And so if you practice these things, I think it'll cover the maximum ground in as short a time as possible. I think, I know that's my theory, because I'm thinking I didn't do this. Someone didn't sit me down and say, all right, now do this now, do this now, do this now. But I did learn this, but it was because I did experience the repetition over a longer time, doing it repeatedly in multiple contexts. Everybody okay? Why didn't anybody fill in the line 50 to 51? Right? Someone should do 50 to 51. You just have to return the average of all of those numbers.
You could start with a for loop.
Who wants to do it?
With int I equals 0.
Yeah, go ahead. Go ahead. Yeah.
And then I is less than random size. Then I++.
This thing that Zach is typing is actually done so many times that it's useful to do, even if right? It's useful to do because looping
maybe
over a vector.
The for loop,
that is
we make a variable
thing, right? You go from 0 to dot size.
Variable to store.
Yeah, and doing this repeatedly,
added up.
automatically you'll know parentheses, everything belongs in the right place. It'll just fall out. Yeah. Okay. There you go. See, float sum equals 0.
Random
and you don't have to start it out saying, well, plan it all in my head, and so I got float sum in my 0, and then do the rest of it. You do the for loop and say, all right, I think I need a sum now, so I'm going to put it there. Okay. So this is what you'll find yourself doing more and more of the time, I think. I know there are some classes that recommend that programmers plan out the entire program and then type it out in sequence, all the variables and so on and so forth. But in practice, in the real world, in the setting, I've never seen that happen, okay, among professionals. Maybe there are professionals who do that, or maybe there are old school professionals who do that, yeah? Maybe with my generation, that stopped being a thing.
And then
that when you write a program, you already know in your head what you need to do, but you don't design the program top down all the way, saying, all right, the variables need to go first. We used to do that in Fortran, right? Very, very long time ago when I did engineering. I had to learn Fortran because, C++ wasn't a thing at that time. They wouldn't let us near the computer until I already had all of the code with variables and everything spelled out in my notebook, right? And that was also because, back in India, the computer center was air conditioned, and I was in a hot city. And so a lot of students would just do, programming to stay off the heat. And so I'm going to do programming and go to the air conditioned room and play with the computer. So they had, also, back in the day, computers were more expensive too, right? Expensive too. So they could only use, they would say, if you want to use the computer, especially the console and the keyboard, you need to come with your notebook and show that this is a program you're going to type, right? Everything. And then there was a supervisor of the computer center will actually know the language, Fortran, and say, all right, that's good enough for you to now go in and type into the console. Okay, so I actually suffered all of that. Not really suffered, it was really fun. But nowadays you don't have to do anything, right? Because anybody, you can program on a phone, on a train. Yeah, well, I actually don't do that because, you know, I'm trying to conserve battery on my phone now on the BART because it's like, you know, 8 hours. But you could technically program on your phone, on a mobile device, anything. And we're using online GDB, right? We're not even using an IDE, and this is week 5. So that is testament to that. All right, now one sec, float sum. Okay, good. Okay, so there is something that you got to watch out for here. So Zach has done something which people may overlook and get bitten by. Okay, so now he's got the division happening in the last line, 57, right? And it's dividing by an integer. Now, however, sum intuitively, or in most cases, triggers in our heads. Oh, sum must be an integer, right? It's rare that we think of sum, especially when a vector that's being passed into us is a vector of integers. So the context is sum. We're in integer space, and a variable like sum instead of x. However, if it was x, I would be primed somewhat because as a mathematician, right? Or someone who knows math, that x is not an integer, but I is an integer. Yeah. So those are cognitive cues you can leverage. But sum, we will think it's an integer, and so integer divided by integer, that's a danger flag. Yes? Yes or no? Because it'll be truncation. However, Zach knew that, and so he said sum was a float. So that is unconventional in a sense, because sum is usually not a float, because it speaks, it bespeaks an integer. However, one of the other ways in which you could do this, in this case it's okay because the function scope is really small. Because even though sum is being used, its declaration is like 3 lines away. But you should try and not do this when you have a function that's like 15 lines big, and you have a declaration there, and you're using it here. Then there's scope. Sum is an integer. However, you can have explicit typecasting there. Does this all make sense when I talk about these things? Because these are things that you'll only pick up by experience, but it is useful to know even as beginning programmers, right? So you can have explicit typecasting. It doesn't cost a lot in terms of runtime because the compiler, it's just signal to the compiler, and you say explicitly typecast this into a float space, right? Even though dot size returns size t, I'm going to make it a float before the division because I want the division to happen in float space. Yes. So you can do these things. And it is necessary for CS2A. It is necessary for CS2A because you did data representation, and then in the first week you did expressions and all limerick and things. Yeah. And so that is supposed to give you practice to know when divisions can go wrong. Now, it is no use remembering that divisions can go wrong sometimes, and then every time you do a division, trying to figure out whether it's going wrong or yes. That way you will get the right answer. Okay, that is the truth of it. You will get the right answer, even if you grind the wheel, meaning that I don't know how things work, I'll figure it out on the fly. You will still get the right answer, but you will be a whole lot slower in getting to the right answer because every time you're going to go into that loop. However, if all of that is internalized and automatic, you'll just be zipping through. And it makes a huge difference when you're actually programming in real life. Okay, and real life doesn't mean that you have to start working. Real life means right now. Okay, because you're learning to program now, and this is the best time for you to experiment and try and get used to these things. Because afterwards, people are not paying you to get used to things, right? People are paying you to make use of things that you've gotten used to on your own. Yeah, so this is a time to get used to these things, and that's why. Yeah. All right. So is everybody okay with this so far? Everybody understand how we're getting the average? Okay, let's go back to our main. Yeah. All right. So we've got the average. All right. Take a good look at the numbers. Random ends.size. Okay. Flush. Right. Get average off. Right. While. All right. So So instead of while 1, let's turn it to while true. Okay. And the reason I say that is because in C and C++, 1 is the same as true. It's C++ gives syntactic sugar, saying we got a Boolean type. It's not really a Boolean type. It's just one or zero or non-zero. Okay. But when we're using C++, let's just honor the C++ way of doing things as much as possible, and say we'll use true and not one, not the C way of doing things. So let's string true. All right, while true. All right. So now put a comment on yeah, while true. What is your name? One of the good things we have to do in UI design is I've got to tell the user how to get out of it. All right. So while what is your name, and within quotes, no, inside, yeah, before the colon, within quotes, before the colon. Yeah, within quote space. Yeah, yeah, and you can say enter done when done. Okay, enter done when done. Okay, so that is useful as a cue to the user to know what they need to do. All right. You want to do that? Okay, great. All right, so get line C in name is good. All right, so now if name equals done, break. Yeah, okay, that's good. All right, now dear. All right, let's not be as nice as Isidore is, okay? All right, so we're not going to say dear and all. We're going to say, all right, maybe all right. So I say, oh, dear John, enter your estimate. Enter your estimate of the average, okay? Enter your estimate of the average. Okay, all right. So now don't use C and right shift, okay? I think well, in this case maybe it works. Yeah. Does everybody know how to do it in a different way? Reading into a string and then extracting it from that. Okay, let's put a to do there. No, this is okay. The way that Isidore has got it is okay. Yeah, put it. Yeah, to do. Someone change the reading of the integer to reading from a stream, okay, using S stream or whatever that is, right? That OS stream or IS stream. So do that, and that will be a variation you need to know. Again, I'm actually giving you all the midterm questions here, okay? This will probably be in the midterm with iString stream, you know, to get to extract a floating point number. How do you do that, right? It's going to be in the midterm, and so this is your practice. You can do that here. Okay. All right. Okay. Now players are pushback and then their guess. Okay. All right. Now instead of double differences and so on, okay, what we'll do is on line 111. Okay, and this is a function, and if we don't manage to complete that function, you're going to complete that function and share this code. Okay, no escaping this. Okay, before Tuesday, you're going to all of you going to work on this code, get a version of this, even if it's identical, that's fine. You're going to say this is Caesar's version of what do we call this? Yeah, average, right? Something like that. Okay, the Caesar's version, and then Brian's version, Ong's version. All right, Julian's version. Everybody's going to post your versions of this code in the forum. And it's also going to be practice for your midterm, okay? So there's no reason not to do it. So everybody, all right? So if we don't manage to finish it, you got to finish it and post it. Okay, so now instead of doing all the differences and all, so go to line 111, hit enter. Hey, Zach? Zach, are you here? Yeah, line 111, hit enter. Zach? Where's Zach?
Sorry, what?
Oh, there you are. 111, 111. Enter. All right. So here, what we're going to do is we have the names of the players. Do we need the name? We don't need the names of the players. We just need the index, right? So put a comment there. Put a comment there saying. Yeah, put a comment there saying we just need the index. We just need the index in the player's vector of the closest guess. Okay. I don't know. Someone's gonna fiddle with the English later on and fix it up. Okay. On the next line. Remember that this vector corresponds place to place with the parallel vector called this vector, not robot. Yeah. Vector. Did you type robot? I don't know. I thought I saw robot there. Vector that corresponds to the parallel vector named guesses. Did you call it guesses? Player guesses. Parallel vector called player guesses. Index for index, right? All right, you can just say, yeah, but place for place, right? On the next line, you can say place for place or index for index. On the next line, you can say index for index. It's very important. Very important. Just keep in mind that is like super duper important. Yeah, okay. So on the next line, you're going to say, right? So winning index equals, right? So you can say, yeah, you actually got it, right? Get rid of line 116. We're not going to use it. Get rid of line 116. Hey, Zach, is there a lag? Is there a lag in the audio going through to you? You just do it, yeah? Right. So, winning index. Get rid of the blank line also. Hey, Zach, get rid of the blank line also. Hey, can you hear me? Are you sleepy or something? Zach. There's definitely a lag. Okay, there's definitely a lag. Is there a lag? Is this me?
Yeah, sorry, my internet is.
Oh, no, I thought there was a lag. Okay. All right. We shouldn't run out of time. All of you are trapped here. Okay, until we finish this. Okay, so nobody leaves. Well, actually, I gotta leave because I don't want to miss my train. Oh, gee. Okay. All right, 2 more minutes. Okay, I'm gonna wrap this up. Okay. So winning index. Yeah, get winner index. Right. And then not winner. Winner. Index. Yeah, get index, and the parameters are going to be, the parameters are going to be real average. Do you have the real average? And then the guesses. Real average, comma, guesses. Yeah. Okay. Now the one final thing you need to do, you need to say, all right. So and to do, put a to do. That is the function you got to do. I'm hoping that all of you will be comfortable with doing that function. If you're not, you got to ask in the Reddit. Okay, ask in the Reddit. I want to do this function. I don't know how to do it. Can someone give me a start? I or Chris or Namrata or someone will jump in and tell you how to get started with this program. Is that okay with you guys? Everybody's got to do it. Yeah, Spencer, all of you guys. Yeah. Okay, great. Now, and by the way, Jonah, you good with that thing, right? That program that we talked about. Okay, good. All right. So, all right. So now the one thing we want to do is when we congratulate the player, we don't want to say you're off by, because if you say you're off by, it's we don't know if it's that side or this side. Yes. Okay. All right. So you instead of you saying congratulations on the next line. On the next line, you can say congratulations and then say endl there, endl. No, after that, yeah, endl semicolon enter. Semicolon enter. You want a semicolon? Semicolon. Right? Now here, what you want to say is your guess was, the actual average was, and the real numbers were. Okay? All of them. The numbers were, the average was, all of them, one after another. That should be the end of the game. Right? But it's in a loop. It'll be going again and again. Right? And because it's in a loop, you can print some horizontal lines so that next round, it's clearly set out. Yeah? That's all. Is that enough? Is that clear? Okay, we covered a lot of concepts today, not just a few, right? Passing by reference, copy, and then refactoring code and turning it into functions. All of this should be second nature to you by Tuesday. It's not Tuesday, Thursday, right? So, but we'll review this on Tuesday too, right? But you shouldn't be depending on us doing this code on Tuesday. We're done. Okay, we're going to be talking about functions, methods and so on going forward. But I want all of you to work on this. If you have any problems, not working, anything like that, you have to ask. Someone will jump in, will help you get something sorted out on Reddit. Yeah, and then you'll all be good with functions. Yes, and you have to know that being good on this is imperative for you to succeed later on, because everything you're going to learn later in the second half is going to build on these things. You can't afford to think about those things when you're doing that. Yeah, great. Thank you so much. Okay, so I'm going to take off now, and I will see you guys online on Tuesday. Yeah, online. It's all yeah. And then we'll meet after the midterm. Okay. All right. Thanks. Take it. Well.